Good morning, madam. My name is Vigneshwaran, son of Balakrishnan, and my metric number is 211092531. Now, we would like to present about the problem-based learning. They have listed 5 main topics, and we have choose the best PBL, that is cybersecurity in power system protection. Why we choose this topic is because we have discussed among with our team members, and we prefer to get more knowledge based on this cybersecurity in power system protection. These are my teammates. Now I would like to present introductions about cybersecurity of power system protection. There are 5 criteria of this introduction. The first one is modern power system as cyber physical networks. It means that power grids now depend on digital communication system like SCADA and PMUS, increasing exposure to cyber threats such as spoofing, DOS, and FDI. Okay, now for the second introduction of cybersecurity of power system protection is cyber threats affect protection accuracy. It means that attack can manipulate relay settings or sensors data, causing misoperation or delays in fault detection, risking equipment failure and blackouts. The third point of the introduction is need for intelligent adaptive protection. It means that BOO 2025 highlights the evolution of undetectable FDI attacks, accommodating machine learning and real-time data reconstruction of improved resilience. Okay, the fourth point of introduction is research scope and the fourth point of introduction is research focus and scope. These studies examines threat models, protection device of modeling, and how researchers validate cybersecurity integrate protection systems. The last but not least, I have studied by Yusufi Kia 2023 and Yushan et al 2020 shows the real-world example of how cyber attacks compromise, delay, and control system accuracy. This is what I research about this topic.
My name is Paitra Aishwanyana from Nagaraju, metric number 221091133. Today I am going to present about problem statement. There I have a 3 problem statement. The first point is overcurrent relays vulnerable to the cyber manipulation. Okay, attacks can alter relay signals through the digital channels, causing false tripping or failure to isolate false risking system stability. For example, hackers can send false signals to the relays, causing wrong trips or missed faults. The second point is dynamic FDI attacks bypass traditional detections. This time, coordinated attacks evade static monitoring methods, making real-time protection and accurate system decisions unreliable. For example, smart cyber attacks can avoid being detected and affect the real-time decisions. The last point is lack of cyber-aware protection system design. Most protection systems are not built with integrated cybersecurity modules, making them unprepared for coordinated cyber physical threats. For example, most protection systems don't include cybersecurity, making them easy to target for combined physical and cyber attacks.
Hello, my name is Muhammad Arif from Sub. My name is metric 211092590. I would like to talk about methodology of cybersecurity in power system protection. The methodology for addressing cybersecurity in power system protection begins with a comprehensive system assessment to identify all critical assets, including SCADA systems, intelligent electronic device, protective relays, and communication protocols. Next, cyber threat identification is conducted to recognize potential attack vectors such as malware, denial of service, phishing, data spoofing, and unauthorized access. Furthermore, mitigation strategies are developed encompassing both technical solutions like encryption firewalls, secure communication protocols, and intrusion detection system, and procedural measures such as access control, cybersecurity training, and incident response planning. Next is risk analysis is conducted to evaluate the likelihood and severity of each threat, enabling prioritization of risk based on their criticality. Finally, testing and validation are conducted using vulnerability vulnerability assessments, simulated attacks, and penetration testing to ensure the effectiveness of the implemented defenses. For the flowchart of cybersecurity and power system protection, it begins with the start node and proceeds to a system assessment where critical components such as SCADA systems, relays, and communication protocols are identified and analyzed for vulnerabilities. The next stage identifies cybersecurity threats involve recognizing potential threats like malware, data breaches, or denial-of-service attacks. This leads to risk analysis where the severity and likelihood of each threat are evaluated to prioritize risk. Based on this analysis, design mitigation strategies is the next step, where both technical and administrative controls are formulated. Once implemented, the system moves to test and validate protection to ensure the defenses are effective through simulated attacks or vulnerability assessment. Finally, the process which monitor and maintain security, establishing continuous surveillance and routine updates to adapt to emerging threats.
My name is Muhammad Amabirosli. I will present about vulnerabilities in power systems. Power systems are vulnerable to cyber attacks such as distributed denial of service (DDoS), ransomware, and advanced persistent threat (APTs). Legacy systems often lack robust security features, making them easy target for attackers. Smart grid, while efficient, introduce additional entry points for cyber threat due to their reliance on IoT devices communication networks. Next, we go to impacts of cyber attack. Cyber attack can disrupt power supply, damage equipment, and cause widespread blackout. Attack on SCADA, which is supervisory control and data acquisition systems, and industrial control system (ICS), can lead to catastrophic failures. Economic losses and reputational damage to utilities are significant consequences of cyber incidents. Cybersecurity measures. Encryption, firewalls, and intrusion detection system (IDS) have proven effective in mitigating cyber threats. Regular software update and patch management reduce vulnerabilities. Network segmentation isolate critical systems, limiting the spread of patterns. Multi-factor authentication (MFA) and strong access controls enhance system security. Challenges in implementation. Balancing cybersecurity with operational efficiency remains a challenge. High costs associated with implementing advanced security measures can be a barrier for smaller utilities. Lack of skilled cybersecurity professionals in the power sector hampers effective implementation. Regulatory and standardization gaps complicate the adoption of uniform cybersecurity practice. And lastly, emerging technologies. Artificial intelligence (AI) and machine learning (ML) are being leveraged for real-time threat detection and response. Blockchain technology is being explored for secure data exchange and transaction management in smart grid. Quantum cryptography holds promise for future-proofing power system securities.
Okay, next I'm going to present about discussion. In discussion, first point is increased risk. Increased risk, the digestion and interconnection of power grids have an increased vulnerability to the cyber attacks. For example, a hacker remotely access a power plant system and disable a protection relay, and the system cannot respond properly during a fault. The second point is expanded attack surface. Okay, use of technologies like SCADA, digital relays, and IoT sensors as a wider the attack surface. For example, attackers exploit SCADA software vulnerability to send the fake commands to the circuit breaker. The third point is critical threats. Cyber attacks can cause equipment damage, service interruption, and large-scale blackouts. For example, a cyber attack shuts down a transformer station, causing power outage across a city. The last point is beyond physical security. Okay, in beyond physical security is a traditional protection are no longer enough. Strong cyber security is now initial. For example, even in the substation, it's is locked and guarded, and online attacks still compromise the protection system without anyone entering the site.
For conclusion, we have four main points for cybersecurity of power system protection. The first one is cyber threats in power system. The second one is ongoing challenges. The third one is emerging technologies. The last but not least, multi-layer cyber security. For the first one, cyber threats in power system is digital technologies improve efficiency but also increase the risk of cyber attacks on power systems. The second point of the conclusion is ongoing challenges. Issues like limited budgets, old systems, and lack of skills staff still make cybersecurity hard to implement. The third point of the conclusion is emerging technologies. New tools like AI, blockchain, and SDN helps detect and prevent advanced cyber attacks. The last point of this conclusion is multi-layer cyber security. It means that we can use firewalls, secure networks, and monitoring improves protection against cyber threats. That's all from us, Doctor. Thank you.